My name is Muhammad Akram Shabasani. I'm here to explain how to solve question 5. So let's take a look on the question first. Propane is dehydrated to form propylene in the catalytic reactor, which is C2H8 to produce C2H6 plus H2. Assuming a fresh feed basis of 100 mole C2H8 into the process reactor, the process is to be designed for a 95% overall composition of propane. Product from the reactor which contains H2, C2H6, and C2H8 leave the reactor and is fed to the separator in order to be separated into two streams. The first stream contains a product which includes H2, C2H6, and 0.55% C2H8. The second stream contains unreacted C2H8 and 5% C2H6 in the first stream, and recycle back to the reactor. So, in this question, there's two sub-questions, which is question A, draw and label the process flow chart, and question B, calculate the composition of the product. So, without wasting time, let's dive into the question A. So as you guys can see, I already draw and label the process flowchart. So at the free entry, there's the basis of the process, which is 100 mole C2H8. It later be fed into the reactor, which is gonna produce C2H8, C2H6, and H2, which are gonna list as N3, N4, and N5. So later then they're gonna be fed into a separator, which is gonna be separated into the two streams. So at the first stream, there'll be N6, which is 0.55% C2H8, N7 C2H6, and N8H2. At the second stream, gonna be N9, which is the unreacted C2H8, and 4 and N10, which is 5% of C2H6. So as you guys can see, before the reactor, there's N1 and N2, which for the N1 is present the initial 900 for the initial 100 mole of propane into the reactor plus the one that recycled back to the reactor. And as for N2, which is purely from the recycled stream. So that's all for the question A. And continue to the question B. We're gonna start it by using overall conversion formula, which is input minus output divided by input multiplied by 100%, which is 100 mole minus N6 divided by 100 mole multiplied by 100% equal to 95% or 95 mole, which is already be given at the start of the question. So we stated that N6 is equal to 5 mole. So after that, we're going to be find N3, which is total propane and the reactive output. So 0.555% N3 is equal to N6, which is stated that N3 is equal to 900 mole. So as for N9, which is the recycled propylene, is equal to N3 minus N6, which is equal to 885 mole. So after that, we're gonna need to balance all three C2H8, C2H6, and H2 balance using the input equal to output formula. So as for C2H8, since propane does not generate in the reaction, so 100 mole plus minus is equal to 5 mole plus C2H8, which makes it as C2H8 is equal to 95 mole. As for C2H6, there's no value in input and consumption. So, and since 1 mole of C2H8 produce 1 mole of C2H6, the amount of C2H6 formed is 95 mole, which is equal as for N7. Because N7 is the output for the C2H8 outside the separated the first stream. So, as for H2, it's the same case as C2H6. So, we're going to take an 8 since it's the output of the for the H2, which is equal to 95 mole, the same value as N7. So after that, it's gonna be the additional calculation for the rest of the N that we didn't find yet. So as the calculation goes, the N5 is equal to N8, which is equal to which gonna result at the same amount of value, which is 95 mole. After that, 5% 5% N7 is equal N10, which is 4.75 mole. After that, since N2 is a mole that be recycled back that purely be recycled back from the reactor, so N10 is equal to N2, which is 4.75 mole. As for N1, like I said before, is the combination of 100 mole of the basis, and from the from the one that we recycle back from the reactor. So 100 mole plus N9, which is 895 mole, resulted as which make N1 is equal to 995 mole. So as the last one is N4, which is N7 plus N10, is 95 mole plus 4.75 mole, which is up to 99.75 mole. So as you can see at the left side of my calculation, the answer for all composition of the product. So that's all from me. Thank you.
I'm going to show the calculation of question 2 and question 3. First, the question says 2 methanol water mixture are contained in separate tanks. The first mixture contains 30% weight of methanol and the second contains 60 weight% of methanol. 250 kg of the first mixture is combined with 200 kg of the second to obtain the product. Question A, we need to draw the process flow chart. First thing first, we need to list down first the information given in the question. Like in the question say, in the first mixture we have 30% of the methanol and 250 kg of the mass. On the second mixture we have 60% and 200 kg for the mass. And then we can draw the flow chart like this. For the first mixture we have 250 kg mass, 0.3 methanol and 0.7 H2O. For the second mixture we have 200 kg for the mass, 0.6 for methanol and 0.4 for the water. And in the question said you will combine, so we just draw like this: mixture 1 combine with mixture 2, and we will get the total mass, which is 450 kg, and we need to find the product composition of methanol and water. We can find it in the next question. Okay, for question B, calculate the mass and composition of the product. First, we already have the total mass of the product, which is 450 kg. So we can find the mass of methanol from mixture 1 and mixture 2. For mixture 1, we can calculate by multiply the mass with the composition of the product, which is 0.3. So I make like this: 250 times 0.3, which I get 75 kg. And then for the second mixture, mass of the methanol, we can calculate by multiply mass, also multiply with the product composition, which is 0.6. So I make 200 times 0.6, which I get 120 kg. And we can get the total mass of methanol, which is 195 kg. Then we calculate the mass of water. For mixture 1, the mass of water we can get by 250 kg times 0.7, which we can get 175 kg. And then for mixture 2, mass of the water we can do by 200 kg times 0.4, which we can get 80 kg. And the total mass of water is 175 plus 80 kg, which is 255 kg. We already calculate the mass for water and methanol. Then we can proceed to find the product composition, which is first for methanol we can do by 195 divided by total mass, which is 450 times by 100%, which we can get 43.33%. That's for methanol. Then for water, H2O, we can calculate it by total mass of water divided by total mass of the product, which is 255 kg divided by 450 kg times 100%, which we can get 56.67%. Okay, for question 3, the question has given us the chemical equation, and the flowchart of the process. In the inlet, we have 100 mol of CH4 and 250 mol of O2. In the outlet, we have 40 mol of CH4, 130 mol of O2, 60 mol of CO2, and 120 mol of H2O. In question A, the question wants us to calculate how much the methane was consumed and determine the fractional conversion of methane. First, if you want to calculate how much the methane was consumed, we have the formula, which is input plus generation equals to output plus consumption. In this question, there's no methane was generated, so we assume generation was 0. And then, if you want to calculate the consumption, we just need to do input minus output, which is 100 mol minus 40 mol, which is 60 mol of methane was consumed. After that, we can calculate the fractional conversion of the methane, which is 60 mol divided by total mol of the CH4, which is 100 mol, so we get 0.6. Next, question B, same as question A. The question wants us to calculate how much oxygen was consumed and the fractional conversion of the oxygen. So, O2 that consumed in this process is 250 mol minus 130 mol, which we can get 120 mol. After that, the fractional conversion of O2 was 120 mol divided by 250 mol, which we can get 0.48. Okay, for question C, write the extent of reaction equation for the product. Use each equation to determine the extent of reaction, substituting inlet and outlet values from the flowchart. Okay, first thing first, in this question we have formula, which is Ni equal to NiO plus Gi and Z. Ni is mole outlet, NiO is number of mole inlet, and then Vi is number of coefficient, and this is unknown. First, we calculate the CO2 first. CO2 equals to Z, which is Z equals to 60 mol. Next, for H2O equals to 2Z, because of in the chemical equation, H2O have two number of coefficient. So, we just substitute the value of NH2O, which is given in the equation, which is 120 mol. So, we just substitute it, 120 mol equals to 2Z. Z equals to 60 mol. Next one, NO2 equals to 250 minus 2Z. This is also in the chemical equation, we have two number coefficient for oxygen. And then we just substitute the value of mol outlet, which is 130 mol, divided equals to 250 mol minus 2Z. We substitute 2Z equal to 120 mol, Z equals to 60 mol. And the last one, for methane, equals to 100 mol minus Z, because number of coefficient only 1. Then we substitute the value mol of outlet, which is 40 mol, equals to 100 mol divided by Z. We substitute arrange.
Okay, so I will be answering for the question number 4. For question number 4, for question A, we need to draw the flowchart. So for the flowchart, which is easy, we just need to find the input and output. So for input, we have the N1C2H4 and N2H2O and N3 inlet. Then for the output, we have the 0.433 mol C2H4, 0.025 mol ethanol, 0.0014 mol ether, 0.093 mol inlet, and balance of water. So for the balance of water, we need to find the balance of water by using the 1 minus with the all all of the information. So after calculate, we got the 0.4476 mol H2O. So then we go to the next question, is question B. We need to find the molar consumption. So at first we need to draw the degree of we need to calculate the degree of freedom. Degree of freedom, we must get the answer is 0. So for the number unknown, we have 3. Chemical equation, we have the 2. Number of molecular, we have 5, and we didn't have the extra information. So 3 plus 2 minus 5. So we got 0. Then we need to find the ethanol balance. So we use the input plus generation equal to output plus consumption. But ethanol didn't have the input, so we just cross the input. Then the formula is generation equal to output plus consumption. So the answer for the generation of ethanol is 2.78 mol C2H5OH. Then we answer the C2H4 balance. We need to find the C2H4 balance for the input, because we need to find the N1. So N1 for the N1 C2H4 equal to output plus consumption. For output, we have the 43.3 mol plus with 2.78 mol. So the N1 is 46.08 mol. Then we need to find the H2O balance. For H2O balance, input plus generation equal to output plus consumption. So we just calculate, then we got the answer is N2 equal to 47.4. We just insert the information that we have. Then we find the inert balance. For inert balance, it didn't have the generation or consumption, so we just use the input equal to output. So input is N3 and output is 9.3 mol. So the question is, we need to find the molar consumption. So for molar consumption, we need to divide with 100 for the N1, N2 and N3. So for C2H4, the molar consumption is 0.4608. For N2 H2O, the answer is 0.474, and for inert, we got 0.093. So for the next question, we use the different law. So at first we need to find the degree of freedom. So number of unknown is 3, independent atomic species is 3, and independent non-reactive is 0. So 3 minus 3 is 0. First we need to find the carbon balance. For carbon balance, we look at our flowchart, and we see if we have the carbon, we need to convert it to for the one carbon only. So as you can see, for the input, we have the C2H4, which is carbon have 2. So we only need the one carbon, so we need to times with the 2 mol of carbon divided with 1 mol of C2H4, because we only need the one carbon. So equal to, as you can see, we have the C2H4, C2H4, C2H5OH, and we have the we have the, what we call it, the ether. So after we calculate, we got the N1 is 46.08 mol of carbon. Then we need to find the hydrogen balance. For hydrogen balance, we just use the input equal to output. As you can see, for the input, we have the C2H4 and we have the H2O. So we need to plus the answer, but we only need one hydrogen. So after we calculate, we got the N2 is 47.4. And inert balance, same, because we didn't have the generation or consumption. So N3 equal to 9.3 mol. So for molar consumption, just use the question B. Question B's answer. So for N1, we got 0.4608. N2, we got 0.474. And for N3, we got 0.093.
Strawberries contains about 15% solid, assuming sugar, and 85% water. To make 1 pound of strawberry jam, equal amounts of crushed strawberries and sugar are mixed in a mixture. The mixture is then fed and heated subsequently, heated in an evaporator to remove water until the product contains 25% water. So to draw our process flow chart, we're gonna start by drawing our mixer because it states there's a mixer. And it states that contain 50% solid, which is sugar, and 85% water. So for here, it's gonna be our sugar, and the other one is strawberries. And it also stays at 50% solid and 85% water. So 50% solid and 85% water. And then it said that it's heated in an evaporator to remove water until the product contains 25% water. So we're gonna go our evaporator here. Evaporator. Which remove water until the product contains 25% water. So the output will be 25% water. So when it says 25% water, which means the other 75% will be our sugar. That will be done for question A. Alright, let's move over to question B. Calculate how many pounds of strawberries are needed to make a pound of jam. We know that mass of sugar is equal to mass of strawberries and input equal to output. Since the question wants us to find how many pounds of strawberries are needed to make a pound of jam, which is the mass of strawberries. To find the mass of strawberries, we can also use the mass of sugar because the input of strawberries is equal to the output of sugar. So let's write over here, and also let's assume X as our mass. So it will be X plus 0.15 X equal to 0.5. This 0.5 came from here, which is 75% sugar, because we are using sugar. And also, if you times it by 1, you get 0.75. So let's solve the question. So here you get 1.15x equal to 0.75. So x will be 0.652. 0.652 lbm. Thus, 0.652 pound m is the amount of strawberries are needed to make a pound of jam. Alright, let's move over to question C. Making a pound of jam is something you could accomplish in your own kitchen or maybe even a dorm room. However, a typical manufacturing line for jam might produce 1,500 pounds per day. Determine the technical and economic factors you have taken into account as you scale this process from your kitchen to a commercial operation. So, from a technical factor standpoint, is ingredient sourcing and quality control. In the kitchen, you may use fresh fruits from a grocery store, but at an industrial scale, bulk suppliers are needed. Second, is we have to ensure the consistent quality, taste, and texture is essential. The next is scaling and cooking methods. Cooking times and temperature are maybe needed to be adjusted for large-scale production. After that is from our economic factors standpoint. From economic factors, our first factor will be operational costs. Labor, energy, raw material must be managed difficulty. Second will be market demands and distribution, identifying potential buyers and managing logistic and distribution works. Third will be pricing strategies and profit margin, ensuring the product remains completely priced while covering production costs.